All right, lesson 7.3, Convergent or Divergent series, geometric series, and the Nth Term Test. So a series is when you add up a bunch of ordered numbers. An infinite series can be written like this, 1 to infinity, and you just add forever. What happens is more and more terms are added to this. This is linear, 1 plus 3 plus 5 and so on. If you keep going to infinity, what's going to happen is it clearly goes to infinity, but the word we're learning to use, down here. So it clearly goes to infinity, get that arrow out of the way. But the word we're learning to use is the word diverges, right? And if you think of what's the right end behavior of that line, the right end of the line is going up forever. It doesn't converge to a number. So when this happens, it said the word divergent or diverges. In example 2, what happens as more and more terms of this is added on? So if you think of the second one, what I want you to recognize is that the bottom is more powerful than the top, in that we can rewrite it this way. That 3 can be written in front Now, if this is a sequence, it would converge to 1 over, this would be 0, and it would converge to 0. All right, so let's try it a little differently then. If I plug in 1, it's 3 over 10. And another way to write 3 over 10 is 0.3. If I plug in 2, it's now 10 squared, which is 100. So 3 over 100, another way to write that is 0.03. If I plug in 3, 10 to the 3 is 1,000, and 3 over 1,000 is 0.003. And I hope you see a pattern as I'm going here. And if I add these together, you would get 0.3 and a 3 and a 3 and a 3 and a 3. This is that repeating. And 0.3 repeating means it converges to an answer, and the answer that it converges to is 1/3. Now, this is an example of a geometric series. So a geometric series is one that's exponential. If consecutive terms in a series have a common ratio, so when you divide, it's always the same answer, 2 consecutive terms, this is the general form of that geometric series. And if r is greater than 1, the absolute value of it, then it diverges. But if the absolute value of the ratio is less than 1, then it converges to an answer. And we have a formula to use where the numerator is the first term, and then 1 subtract what that common ratio is, and it will converge to an answer. So if I look at number 3 and look at it, first of all, does this converge to an answer? Now, if I look and multiply it out just a little bit, plug in 1, plug in 2, plug in 3, what I hope that you see is that the common ratio is 1/2. That you're just multiplying by a half to get there, multiply by a half to get there. And is this common ratio less than or equal to 1? Yes. So it converges. What formula do we use if it converges? So the numerator is the first term, which is 3 over 2. The denominator is 1 subtract the common ratio. And then I simplify that. So what I have is 3 over 2 divided by a half. When you divide by a half, you multiply times the reciprocal. The 2's cross out, and you have the answer, which is 3. Oh, wait a second. When I plug in 1, I'm supposed to plug in 0. So when I plug in 0, it's the same thing, but the first term is going to be off. So when you plug in 0, 2 to the 0 is 1. So this first term should have actually been 3. See if I get it cleared up. So the first term should have been 3, so I should have plugged in 0 first. It's still 1/2. The only difference is the first term then would be 3, and then when you multiply by the reciprocal, this answer now will be 6. If I look at number 4, what's different about this is that this common ratio in this form is 3 over 2, and 3 over 2 is bigger than 1. So because the common ratio is bigger than 1, it diverges. And we can actually use the acronym GST, which is by the geometric series theorem. And we can also say that here. So they say, why do you know that? So this is the geometric series theorem that says if the ratio, the absolute value of the ratio is less than 1, it converges. This, it's bigger than 1, so it diverges. Here, you can see the absolute value of 1/2 is definitely less than 1. So this converges. Why? The geometric series theorem. What's the formula then we use? So plug in 1, not plug in 1. You get 4 times -1/2, and then it's 1 subtract the ratio. When you subtract a negative, you're adding, so it's 1 plus 1/2. And then multiply times the reciprocal, and you get -4/3. In example number 6 says find the fraction form of the repeating decimal 0.08 using a geometric series. So if 0.08, 0.08, 0.08, so 0.08 is 8 over 100. And if there's another one, 0.08, it would actually be like adding 0.008. So if you add these together, it would be 0.08, 0.0, let's make sure I did it right. Yeah, 0.08. So if I add these together, it would be repeating. I want to go 0.8, 0.8, 0.8. So this would be 8 over 10,000. And then that would create a pattern. I go 0.00008. That'd be 8 over 1 million. So by seeing that, I'm going to write this to infinity and think, well, I don't even need to write a series. I just need to know what the common ratio is here. And so 8 over, what am I multiplying times? And so I'm multiplying 1 over 100 every time. Because 0.08, that's the common ratio, 1 over 100. And the first term is 8 over 100. So the formula then would be the first term divided by 1 subtract in the common ratio. This is 8 over 100. I'm going to change this to 100 over 100. So when I subtract, it would be 99 over 100, but we want the reciprocal. So 1 subtract 1 over 100 is 99 over 100. And then do the reciprocal. Notice the hundreds divide out. And what fraction is equivalent to it? And the answer is 8 over 99. In general, convergence of a series is less simple than convergence of a sequence. So if we have a series, it's a little bit harder to tell whether it converges or not. The sequence converges because this goes to 1. Because when the bottom is more powerful, that answer is 0, so 1 plus 0 is 1. However, this series does not converge. It just gets bigger and bigger and bigger and bigger. A series cannot converge unless the terms approach a limit of 0. This does not approach a limit of 0. It approaches a limit of 1. So if the limit would equal 0, not 1, then yes, it would converge. So that's the nth term test for a divergence. So if there's a series and the series has a limit and it approaches 0, then it converges. So if I look here, n factorial over 2n factorial plus 1 as it goes to infinity. See the power terms? So if you divide out the power terms, you're left with 1/2. So this diverges because of what's called the nth term theorem. That's what this is. The nth term test. Sorry, not theorem. So the nth term test, NTT, that this would have to have a limit that approaches 0 to converge. If it's any other number, it diverges. I think that's it. Mr. G Math over and out. Till next time, we'll do our work together.